So, semiconductor memories, so these are one of the very important component, like if you look into any digital system, because we have seen that if you want to store some information in a digital system, then one possible storage that we have seen are the registers. But you see, registers are quite costly, because for making one register, so you will need a number of flip flops and some control logic like that. So, if you are willing to store large amount of information and then you want to access those contents, then we need some mechanism by which it can be done in a much better fashion, not via some circuitry to access individual flip flops. So, the semiconductor memory design, so this will tell us like how these things are done, and what are the functionalities of this memory, and there are many memory chips available. So, of different types. So, what are the general control lines that you should expect in a memory chip, and how is the memory organized in a system. So, we will be looking into these aspects. So, there if you look into this memory, there are two broad types of memories that are used in digital system. One is known as random access memory or RAM, and another is read only memory or ROM. So, in random access memory, so you can perform both write and read operation, and in read only memory, so you can perform only the read operation. So, though this name random access memory is somewhat misleading, so it means that there is some, as if there is some other memory which is not random access, which is sequential access. This is true, but sequential access memories are there, but they are no more used in the computer systems now. But the both random access memory or RAM and read only memory ROM, so they are actually random access. So, there is no order in which you have to access the locations in these chips. So, you can tell the location address, and the memory will be able to access that particular location. So, the basic difference between a RAM and a ROM is that in case of RAM, so you can do both write and read operations. So, either that is you can modify the content of a location in the RAM, or you can read the content of a location in the RAM. Whereas, for read only memory, so it is you can only do read operation. So, normally if the information is not going to change, for example, say the some part of the operating system, which is the memory resident part of the operating system, which is not going to change, which is commonly known as the basic input output subsystem. Okay. So, those or the monitor programs, so they are actually kept in the ROM, because they are not going to change. Similarly, if you are thinking about some other application where say some filtering of application, where you have got a set of filter coefficients. So, these filter coefficients may be kept in a ROM, and then we can do the operation. So, the filter coefficients are not going to change. So, they can be kept in a ROM. So, this read only memory is a programmable logic device. So, this is programmable logic device, means you can program it, and you can put some content there. So, random access memory, so you can the user can change the content at any point of time, whereas this programmable logic device based read only memory, so you can change the content, but only with some restrictions. So, you cannot change the content while the system is in operation. So, either you have to take out the chip, or you have to stop the system functionality and do some modification to the programmable device. So, apart from this read only memory, which can act as programmable logic device, so there are other programmable logic devices like programmable logic array. We have seen some part in our discussion previously, the programmable array logic or PAL, and field programmable gate arrays or FPGAs. So, we will be having some we will be looking into these devices also to some extent. So, to start with, we will be looking into the random access memory. A memory unit, it stores the binary information in groups of bits called words. So, as we know that in case of a register, so if I say that it is a 4-bit register, so 4-bit register, then we know that these 4 bits may be contained in 4 flip flops. So, the same concept we have in this random access memory. So, we have got a few locations of this memory chip which are accessed together. Okay. So, this may be there may be 8 such bits which are accessed together. So, that constitutes a byte. So, these 8 bits will constitute a byte, and depending upon the memory design, in one memory access, so you may get the content of you may get the content of 1 byte or maybe more than 1 byte. So, this is determined by these lines, like if you see that I have got a memory unit like this that has got n data input lines and n data output lines. So, if you are accessing a particular location in this memory, so it will be you will be getting data in terms of n bits. Okay. So, if you are trying to modify something, so you have to give n bit data here, which will be written at some a set of n bit locations, or if you are trying to get the content of this memory for a particular location. So, you will get this n bit data. So, these individual bits of memory, so they are accessed in a group. Okay. So, that will be called, that we will call a word. So, that is known as the word size of the memory. So, word size is normally equal to 2 bytes or 4 bytes, like that. So, there is no hard and fast rule like what should be word size, but word size is never less than 1 byte, of course. So, so you can in your computer system, so you may have different word sizes. So, communication between a memory and its environment is achieved through data input and output lines, address selection lines and control lines. So, you can think about this memory as if it is having 2 to the power k words and each word is n bit. So, you can think that as if my memory is like this. So, it has got 2 to the power k such words, okay, and each location is consisting of n bits. So, this side you have got n and this side you have got 2 to the power k. So, if you can think of this memory as a collection of cells, and number of cells is equal to 2 to the power k by n. So, these individual cells you have got 2 to the power k by n, but the point is you cannot access a single cell alone. Okay. So, if you are trying to access a single cell, so you have to access this entire location. So, so there are some so every location has got an address. So, if this may be address 0, this may be 1, this may be 2, this may be 3. So, it goes like this. So, for example, if I ask for the content of location 100, so it will give me an n bit pattern that is the content of that location. So, we have got this memory unit that consists of 2 to the power k words and each word is n bit wide. So, these k address lines are to be given to tell which location we are trying to access. So, then this n bit data input and output lines are there. If you are doing a read operation, then the content of that address location will be available on this n bit data output line. On the other hand, if you are doing a write operation, so whatever value is available on this n data input lines will be stored in the corresponding location. So, these control lines, the read and write, so they specify the direction of the transfer. So, this is the idea of this basic random access memory. So, each word in memory is assigned an identification number called an address. So, these are the addresses like the each location. So, this is address 0, this is address 1, this is address 2, like that. So, this is up to address 1023. So, in this particular case we have got 1024 locations, 1 kilo memory locations, okay, 1 kilo memory addresses. So, the k equal to 10 in this case. So, the addresses will go from 0 to 2 to the power k minus 1. So, addresses go from 0 to 1023, k is the number of address lines, and number of words in a memory with one letter that is k, we will now write it in the k, which is kilo, which is 2 to the power 10, mega m 2 to the power 20, or giga 2 to the power 30, like that. So, 64k, that is equal to 2 to the power 16. So, k is 2 to the power 10 and this 64 is 2 to the power 6. So, that gives us 2 to the power 16. Similarly, 2 mega, it is 2 to the power 21. Now, if you write a whether it is byte or word, etc. So, that will be written here, like if I write like 64 kb. So, if I write like 64 kb, so that means individual locations are having 8 bits. Okay. So, this way we can tell the number of locations in the memory chip. So, if you try to do write and read operations, so first of all we will look into the write operation, which is to transfer a new word to be stored into the memory. So, for that what we have to do is that we have to apply the binary address of the desired word to the address lines and apply the data bits that must be stored in the memory to the to data input lines, and we have to tell the write input. So, we have to, so if you look into this diagram, for writing we have to give the address lines, we have to give the data value, and we have to keep the write control signal. So, read control signal should not be activated. So, that is how this write operation will take place. Similarly, we can do this read operation, which is basically transferring a stored word out of memory. So, here also it is similar. So, apply first the binary address of the desired word to the address lines, activate the read input, and so then the content will be available on the data output lines. So, commercial memories they sometimes provide two control inputs for reading and writing in a somewhat different organization. So, basically the problem that we have with the configuration that we have taken, like say we have said that we have got a memory chip memory like this, and it has got two controls, one is read, another is write. Now, in this situation how do you tell that which operation you are trying to do? So, it may be the situation that I do not want to do either read neither read nor write operation. So, I do not want to do any of those operations. Okay. So, somehow there should be a mechanism by which I should be able to distinguish between the situation that say I do not want to do any of the operations. So, this one possibility is like this memory chips they come with an enable input. So, if this enable line is 0, then whatever be this read write value, so no operation will be done. If enable line is 1, then if the read write bit is 0, so that is a write operation, and if enable is 1 and read write is 1, that is the read operation. So, in many processors we see that it is written as read write bar. Okay. So, so the control lines is written as read write bar. So, if this enable is 1 and read write bar is equal to 0, that means we are trying to do a write operation. Similarly, if this line is 1, that means we are trying to do a read operation. So, this is the organization of these control signals, memory read write operations and all. So, typically this memory access can be represented by means of a timing diagram. So, what happens is that this memory chips they are connected to some processor for this, which will be doing the operation. So, in our from our school days, so we know that if I have got a processor, then this processor and memory they are connected by means so they are connected by means of some lines, and then whenever processor needs to write something onto the memory, so it will send the data to the memory. Similarly, when it wants to read, so it gets the value there, and this line that I have shown here, so this is not a single line. So, we will have the situation like this. So, these lines they can be divided into at least 3 different set of lines. So, this side is the processor, this side is the memory. The first set of lines they are the address lines, then we have got the data lines, these are the data lines, and there are some control lines, these are the control lines. So, which basically the read write or this enable, so they go as the control lines. So, this processor how does it operate is that, so processor operates at some clock. So, so this suppose this is the clock signal where the duration of this clock signal period is 20 nanoseconds. So, this is just an example. Now, this so at T1, so this the processor will put the address onto the address bus. So, address will be valid for the entire time T1, T2, T3 all the 3 cycles, and then after putting the address onto the address bus, this memory enable signal is made high. Then this read write bar line, so this is made low because this is a write operation. So, this read write bar line is made low, but before that, so data is put onto the data bus. So, you see that these 2 points, so they occur simultaneously, that is the memory address is made a valid address is put onto the address bus, valid data is put onto the data bus. After that, the memory signal, memory enable signal is given, and this read write control is made low, so that it is a write operation. Then the memory will be doing the operation. So, how much time this memory takes to respond with the data, so that is given by the cycle time. So, this is this memory the access time and cycle time of the memory must be within a time equal to the fixed number of CPU clock cycles. So, access time means how much time it takes to access the memory. So, for how much time this read write this address input, then this read write control input should be valid, so that memory will understand it. And cycle time means after you have put the address data and say control lines, after how much time the operation will be done by the memory. So, that is the cycle time. So, this memory enable and read write signal must be activated after the signals in the address lines are stable, to avoid destroying data in other memory words, because otherwise what will happen is that if these signals are given before they become valid, so they are having some wrong values, and if you give an enable and this read write signals before that, then the memory will access some other location and that location's content will be lost, that location content will get destroyed. So, this is the problem. So, it is always advisable that we first put this make this address and data lines valid, and then only we give these control signals. So, this enable and read write signals must stay active for at least 50 nanoseconds. So, this is a typical situation, like if your clock CPU processor clock is of period 20 nanosecond, then this read write signals are expected to be active for about 50 nanosecond. So, next we will be looking into the read operation. So, in case of read operation also, the CPU can transfer data into one of its internal registers using this negative transition of T3. So, here also the operation is like this, the address valid address is put, memory enable signal is made active, and this read write bar line is made active. So, this is made high. So, this is read operation is done. So, after 50 nanoseconds, so if the memory cycle time is 50 nanoseconds, so after 50 nanoseconds the data is available onto the data output. So, this data valid comes here. So, processor should take the data at this point. So, it has started the write operation at this point, but it should take the value at this point. So, this negative transition of T3, so this falling edge of T3, so this should be used for storing the data into the CPU register, because at that time only the data is valid, the data is definitely valid at this point of time. So, this is the way these read operations will be done. So, if you going back to the types of memories, so in random access memory the word locations may be thought of as being separated in space, with each word occupying one particular location. So, so we can think of it logically as if we have got, in case of this random access memory, so we have got a set of locations. So, all these are locations, and you can access any of them randomly. So, there is no fixed ordering in which you have to access them. On the other hand, this sequential access memory, information is stored in some medium is not immediately accessible, but is available only certain intervals of time. So, basically this is true for magnetic disc or tape type of devices. So, there what happens is that we have got this type of discs, and there are some tracks in it. Okay. There are some tracks which are further divided into sectors like this, and there is a read write head. So, there is a read write head. So, suppose this is the read write head. Now, so this disc rotates, and accordingly whichever comes under this read write head, so that value is read at that point. So, since this disc is rotating, so after you have accessed say this location, then only you can access this location. If I assume that the disc is rotating like this, so you cannot access randomly. So, it cannot be the case that first you access this, then you access this, then you access this. So, that cannot happen, because if the disc is rotating like this, and the initial read write head is at this point, then this content will be read first, then this content, then this content. So, that is a sequential access. Okay. So, this semiconductor memories, they are mostly random access type, and this secondary storage like say disk and all, so they are of this sequential access type. So, in random access memory, access time is always same regardless of the particular location of the word. So, it does not matter which location you are accessing, the accessing location 100 or location 200, they take same amount of time. Whereas, in a sequential access memory, the time takes to access a word depends on the position of the word with respect to the reading head position. As I was telling previously, that since the disk is rotating and if the word that you are trying to access is close to the read write head, then it will be accessed much faster compared to the situation where this actual data point is will come much later. So, it is not adjacent to the current head position. So, in that case it will take time for the disk to rotate and the head get aligned to that location. So, this is the problem. So, with the sequential access and the access time becomes variable. So, in case of random access memory, so depending upon the technology we can immediately find out what is the access time, but in case of sequential access memory, so it depends on the location that you are trying to access, accordingly the access time will vary. So, static RAM or SRAM, so this is one type of random access memory. It consists of essentially it has got latches that store the binary information. The stored information remains valid as long as power is applied to the input. So, SRAM is easier to use and has shorter read and write cycles, low density, low capacity, high cost, high speed, high power consumption. So, these are the features of this SRAM. So, this low density means per unit area how many such memory cells you can put. So, low density means, so you cannot make the density high. So, you cannot put large number of memory cells in a short in a small area. Low capacity, so if the density is low, then naturally capacity will also be low, because how many such cells you can put into the chip. So, that way the capacity will be low. Cost is high. So, cost is high because you are putting less cells there. So, the cost is going to be high, but the advantage that you get is the high speed. So, speed of operation is high, the access time is faster, power consumption is also high. So, these are the problems with static RAM, but still they are used because of this the speed, the high speed property. There is another variant of this RAM which is known as dynamic RAM or DRAM. So, it stores the binary information in the form of electric charges on capacitors. So, in case of static RAM, what happens is that, so conceptually a static RAM is like this. So, you have got two inverters which are connected back to back. So, which are connected back to back. So, once this is say equal to 1, so this is equal to 0, since this is equal to 0, so this is equal to 1. As a result, this point will always remain as 0. On the other hand, if this value is say 0, then this will be 1, so this will be 1 and this will be 0, and that way this point will always remain at 1. So, the static RAM, so very simplistic structure, so that will be, that can be formed by connecting to back inverters, but that way the cost of the system goes high. There are other constructions of this SRAM, so we will not go into that. But in case of dynamic RAM, what is done is that we do not have the such back to back inverters, rather we take a capacitor. So, the capacitor is charged and this capacitor is actually holding the charge. So, if you are trying to store a 1, so this capacitor is charged, and so naturally, so it will, so if you sense the value here, so you will get a 1. On the other hand, after some time, of course, we cannot make a perfect capacitor. So, this capacitor will leak. So, after some time the voltage level will come down as the charge leaks from this capacitor. So, it will go towards 0. So, this is the so what is required is that we need some sort of refreshing. So, this DRAM or dynamic RAM, it stores binary information in the form of electric charges on capacitors. The capacitors are provided inside the chip by means of MOS transistors. So, we have seen CMOS logic. So, the MOS transistors we have seen there. So, they are the gate of it acts as the capacitor. So, this gate value, the gate part of it acts as the capacitor to hold the bit pattern, bit value. And the capacitors, as the capacitors they tend to discharge with time. So, periodically we must recharge the dynamic memory. So, this compared to static memory, which does not require any extra circuitry for holding the value. So, in case of dynamic memory, periodically you have to read the content of the memory and write it again. So, that way we should have a refreshing circuitry. So, it is so apart from this, if this is your DRAM chip, then along with that I should have a refreshing circuit. So, what this refreshing circuit does is that it reads the content of individual locations and write the same value there. So, since it is written periodically, so this the capacitors will get recharged and then the value will be restored to their original one. So, this is the idea of this dynamic RAM. So, of course, we do not go into the circuit part. So, in case of dynamic RAM, so it offers reduced power consumption. So, that is one of the largest advantage that we have with DRAM. Storage capacity is high because only a single capacitor is needed for making a DRAM chip, a DRAM cell. So, that way this whereas in case of your SRAM cell, so standard SRAM cell it requires 6 transistors, whereas standard DRAM cell it is requiring only a single transistor. So, that way the capacity is much higher and high density, high capacity, low cost, low speed, low power consumption. So, this low speed because it requires this refreshing, periodic refreshing. So, speed is not that high as this SRAM configuration, but it is still used because very much because of this high density and high capacity and low power consumption. So, memory units that lose stored information when power is turned off are said to be volatile. So, all these chips that are static RAM or dynamic RAM that I am talking about. So, if the power is turned off, then the content is lost. So, this type of memories they are known as volatile memory. Both static and dynamic are of this category, since the binary cells need external power to maintain the stored information. There are non-volatile memories like magnetic disk and ROM that retains its stored information even after removal of power. So, in a ROM, so the information is stored permanently. So, you can switch off the ROM, but still get the content there. When later on also the content will be there, but for RAM it will get destroyed. Next we start with memory decoding. So, memory decoding process. So, this will be it will try to figure out like how this addresses will be selecting a particular location, and then so here we can logically we can think of as if there is an SR flip flop, and then this SR flip flop is getting selected by means of this read write lines. So, so this is just a logical diagram. So, ideally it does not happen like this. So, that is there are separate course on memory design. So, that we will be talking about this cell design part, but for our course, so we will be looking into this logical diagram and try to understand the philosophy of operation.